When you hear EV or electric vehicle charging and DC fast charging, maybe they sound like two completely different things. Actually, DC fast charging is just the fastest level of EV charging. There are 3 levels to EV charging, including level 1, which uses an 120-volt AC wall outlet. These wall outlets are the most common, and you might use them to charge your phone, for example. Level 2 uses a 240-volt AC wall outlet. This outlet might be used for things like ovens or dryers. Then there's level 3 EV chargers, which are also called DC fast chargers. These supply 480 or more volts of electricity, with the main difference being that they supply DC electricity rather than AC. Let's switch gears for a second. You might hear that one of the main reasons EVs haven't surpassed internal combustion cars in the market is because they're too slow to charge. This is true, but it's actually a simplification of the problem. The problem is really when level 1 or 2 EV chargers are used. They are the problem because they're the slowest yet cheapest option for charging EVs. Level 3 chargers are much faster at charging. Let me give you an example. Level 1 chargers could charge a Tesla Model 3 in up to 35 hours. On the other hand, level 3 chargers or DC fast chargers can charge a Tesla Model 3 in less than 30 minutes. But what makes level 3 charging so much faster? Well, there are 2 things that make level 1 and 2 chargers slower than DC fast chargers. The first thing is that level 1 and 2 chargers charge at lower voltages than DC fast chargers. According to the formula we use to calculate power, when voltage is raised, current is lowered. And more current also means more heat, and heat is actually wasted electricity. So sending higher voltages not only means more total power is sent to a load, but also that less energy is wasted along the way. The second reason level 3 chargers are faster is a little bit more complex, so stay with me. Level 1 and 2 chargers supply AC power to EV batteries that need DC power. You can't charge EV batteries, or any battery for that matter, with AC power. So the AC electricity flowing into an EV must be converted into DC power to charge the battery. This AC to DC conversion is done by a device called an onboard charger that's built into EVs. When AC power, with a high current and lower voltage remember, is sent to a battery, more heat is generated, and this heats up the converter or onboard charger, so the converter can only convert at a rate where it's not overheating. This means that the converter is a little bit slow, and so when it's necessary in an EV, it slows down the charging process immensely. Basically, DC fast charging supplies DC power directly to an EV's battery, and so bypasses the EV's onboard charger. And there you have it, the 2 reasons why DC fast charging is so much faster in less than 5 minutes. Thank you for watching. I'm Erin from Argentum, and we provide a high voltage DC power system for buildings so their electrical system can be just as efficient as level 3 chargers are for EVs. Let us know in the comments if you learned something new. And don't forget to subscribe if you want to see more stuff like this.